I know. Welcome back to the drive-thru, everybody. I'm here with Mr. Pletz. We're trying to figure out this question 25. We can figure it out, but getting it right is a whole different story because there's a whole lot you can get wrong here. So if you're doing this problem for like the third or fourth time, well, welcome to the party. So are we. Okay. Here's what my advice would be. One, write the vectors, or write the info as vectors. Okay? In this problem, what you're going to do after you get them as vectors is you are going to add the two vectors. And then step 3 is always take your time and interpret. I don't know how to spell this. I don't know. Maybe this. The data properly. Or let's see, interpret the vector properly. Alright, so here's what we got going on. We have two vectors. Well, I'll box them. So this one's going to be our red vector. And this one will be our green vector. And then before we do that, let me re-explain what this means. This is read the number, then the letter on the right, then the letter on the left. So it's 40 degrees west of north. Okay? So, if this was our point, and this is north, we want to go 40 degrees west of that. And if you think about it, we're usually on the XY plane for these. So this angle is 40 plus 90, 130 degrees. So this red vector will be 1680 times the cosine of 130 and the sine of 130. Okay? Now, the green one is 55 degrees west of south. So here's south. 55 degrees goes that way, which means we have 35 degrees here. Add 35 to 180, and this whole thing, let's see, 180 plus 35. 215 degrees is that green vector. So this one we will write as 1280 times cosine 215 sine 215. So now you might stop and pause the video and be like, okay, did I interpret the angle right? And because that's what I was doing wrong in my previous example. All right, now, I'm telling you, I'm not even going to take the time to write these out because that's what I've been screwing up part of the time, and I've been rounding wrong. So here's what I'm going to do. First, let's interpret the vector geometrically. So if I took that green vector and I just added it to the tip of the red one, essentially making a parallelogram, that should geometrically represent the answer. So man, a lot of this is getting pulled left or west. Okay? Now, to get this blue vector, I'm going to do 1680. Oh, let me make sure we're in degrees. We're not, so I always got to turn it back in degrees when I turn this thing on. It's like very important. It should be a class in itself. 1680 times the cosine of 130 plus 1280 times the cosine of 215. That gives you this first entry. So you negative 2128.39. I better keep going. 0.3978. Okay, now let's add these terms up back into my calculator. Now we can do 1680 cosine of 130 plus 1280. Oh, that should be sine. Dang it, dang it, dang it. Sine. Sine. Plus 1280 sine of 215. All right, let's see what we get for that. 552.77. 7768. All right, so when it asks for the magnitude of the resultant force, we're going to do the square root of a squared plus b squared. This is a, and that's b. So let's see if we get that right. Square root. I'll put negative in there just so you guys feel better. It doesn't matter. 2128.3978 squared plus 552.7768 squared. Enter. Oh no. Okay, let's just, it wants parentheses. Of course it does. Okay, I'm going to just not negative that because it's going to save me so much time. And this will still work for this one. Let's see if that gives it to us. Bam. Is that right? 2199.01. Okay, now, this is your vector. So you've got like this little right triangle here. We're going left this much. And we're going up this much. So in order to find the angle, we use tangent inverse. So tangent of theta is opposite. So 552.7768 divided by the adjacent, which is negative 2128.3978. So we're going to do the tangent inverse of both sides. So second tangent 552.7768 divided by negative 2128.3978. Enter. All right, now it doesn't know where it's at, so it tells you that it's negative 14.55 degrees down this way. But you know that what it really is it's this way. And that's why you have to sketch this figure to figure out which quadrant it's in. So then to interpret the actual direction angle, you have to do 180 minus 14.58, and that's how they give that. Tough question. Boom!